All right, oh, and we're recording. Okay, so welcome to everybody, especially if you've been absent. All right, so take a look at the screen. You're going to see these are the constructions that we're looking at here these first 2 or 3 weeks. Copy an angle, a segment, bisect an angle in a segment, create a line parallel to another line, perpendicular to another line. Divide a segment into equal parts. You don't need to write these down. Just take a look. Perpendicular bisector of a segment. A perpendicular to a line through a point on the line, and perpendicular to a line through a point not on the line. Then we're going to look at some triangle, investigate some triangle stuff. Medians, altitudes, angle bisectors, things of that nature. So that's kind of I estimate this will take us 2 to 3 weeks for all these constructions. All right, you guys got a compass and a straight edge? All right, go ahead and get out a piece of paper. We're going to start our constructions. You can use a protractor, you can use a ruler, and you need a compass. Those are the tools. Those are the tools of the trade. Let me make the screen a little bit bigger. Okay, so construction number 1, go ahead and label the top of it. It does not matter if you use portrait or landscape view. Construction number 1. All right, so we're going to teach you how to copy a segment. Now again, we don't want to use the numbers side of a ruler, like we're not measuring a segment saying, oh, it's 3.5 inches. No, 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 no. We're just using the straight edge part of it. Okay, so to start us off with, use your straight edge. Doesn't matter how long, but go ahead and create a segment. It can be random length. That is a segment AB. Many times it's denoted with a segment over top. A and B are what we call endpoints because that's where the segment ends. All right, so now we're going to copy segment AB onto another space. And to do that, I need to draw a ray. So there I have a ray. The difference between a ray and a segment is a ray has an arrow on one end. Allie, what do you think the arrow represents? It's ongoing. I like that word. It's ongoing. It keeps going and going and going and going. It doesn't end. You got to use your imagination. Watch my pen. It keeps going and going and going and going and going and going. Oh, we get to the end of my screen. Does that mean it stops? No. Use your imagination. It keeps going and going and going, and so much so that it goes to the bookshelf over there. Then it goes to the wall. Then it goes outside. Then it goes to the greenhouses. Then it goes across Raider Road. then it goes through the back of people's yards, then it goes through Mechanicsburg, cross Mechanicsburg, then it keeps going, and it doesn't stop. You got to use your imagination. What's a mathematical word for it not stopping? Where does it go to? Infinity and beyond. That's what the line represents at this half of array. Any questions? Okay, so now that's not what we're doing right now. We're copying AB onto this array. Here are the steps to follow. I have a compass. I put the sharp point on one endpoint. Let's say it's on A. If I make an arc right now, that's not long enough. That doesn't go all the way out to B. Does everyone see that? So I have to widen out the compass. Another term for that is the radius of a circle. Widen out. What if I go too far? That's no good either. I want to be precise. So I want the pencil tip to intersect with B, which is a point. So A and B are end points. Look back here at my desk, please. I'm going to do it on the screen with both fingers. When I put my fingers together, that's a point. Got it? Now, so a point doesn't have substance. It doesn't have mass. It doesn't have shape. It's undefined, which is kind of weird because we start off geometry with an undefined term, which is a point. But we represent a point by putting our two fingers together. That's a point. Or the tip of this sharp point on the compass. That's a point. Or the tip of a pencil point. That's a point. Does that make sense? It's kind of hard to describe. Basically, we represent a point with a dot. So a dot represents the point. All right, so back here, we've got the idea of what a point is. I want A to B to go exactly from point A to point B, and I want to be precise. Does everyone see how that matches up? You need to match it up on yours. Then don't let it move on you. Go down to the ray and put the sharp point on the end point and make an arc on the ray. Now where that arc intersects the ray, there's a point of intersection right there. I'm going to make a dot. That's a point. That represents the length of CD. So I know that AB is equal to CD. Ta-da! You just copied your first segment. Tanner, any questions? Okay, use the length of AB again, but this time, let's make our array at an angle. Alright, so I'm going to act like my compass moved. Oh no, my compass moved. I got to come back and do it again. Yep, that's too long. I'm going to move my pencil so that's right at B. I like showing arcs because it kind of shows that I know what I'm doing. Now I'm going to go down to this angle. Ray right there. I'm going to create a point of intersection. And there I've done it again. AB is equal to CD. See, it doesn't matter the direction that we're going. In fact, we're going to do it again. But this time we're going to do vertically. So I'm going to do a random length of AB. Does not matter how long it is. I'm going to make this one a little shorter. There's AB. Now I'm going to do a ray. Now I'm going to copy segment AB onto the ray. Doesn't matter if I put my sharp point at B or my sharp point at A. Doesn't matter. It does not matter. I can go either direction. It's probably good to have an extra pencil, and I don't overuse the pencil that's in my compass. Alright, so I'm going to put it on A and work my way down to B. I'm going to take my glasses off so the old man can see. Alright, let's make an arc. Is that right at B? Caden, what do you think? Is that arc right at B or is it too long? I agree. I think that's precise. Alright, so don't let my compass move. Now I'm going to go over to the ray, put it on the end point, and make an arc. Tanner, does that make sense? Allie Sanders, that makes sense. So then, it doesn't matter what I label these, I just like using the next letters in the alphabet. AB then is equal to CD. It doesn't matter if it's horizontal, if it's at an angle, or if it's vertical, it all turns out the same. Everyone good? Okay, let's go to the next type of construction. Go ahead and use your straight edge and create a random triangle. It can be an isosceles triangle, it can be an obtuse triangle, it can be a scalene triangle, it can be a right triangle, I don't care. But I got a random triangle A, B, C. Okay, now what I'm going to do, here's my directions. I'm going to copy all three segments, or in this case, sides of triangle onto a ray. And not three different rays, but one ray. So I'm going to make a long ray down here. And I'm going to copy ABC, each segment, onto this ray. Here we go. I'm going to do it 3 times. Doesn't matter the order, because I'm going to do all 3 of them anyway. I'm going to go from A to B out here. Oh, that's a little short. I'm going to go a little wider. There we go. Give myself a dot. So that represents AB. Everyone good there? Okay, now I'm going to go from B to C. Probably a different length, yep. There we go, BC. Now I'm going to start at B. I'm going to not start with A, but I'm going to start with B. And go B to C. So that represents AB and then BC. Dom, does that make sense? Okay, got one more to do now, my third one. I'm going to start with C and go back to A. It's a little different length. Okay, C to A. Boy, I almost didn't have enough of my array, but I do. So that's C to A. Okay, so what happened? So I have segment AB side plus BC plus CA. If I were to outline it, I'd go from A all the way to A. What's it called when you add all the sides of a polygon together? Does anybody know that special term? Perimeter. Who said that? Good job, Mia. Perimeter. So that segment that I just outlined from this point to this point represents the perimeter of the triangle. All right, has everyone got it? All right, I want you to do it again at your seat. But this time, if you didn't, I want you to use an obtuse triangle. It can be random lengths of sides. Don't care the lengths of the sides. An obtuse triangle. Now on a quiz, it might be worded like this. Find a segment equal to the perimeter of triangle A, B, C. All right, go ahead and do it at your seat. Okay, I'm gonna do it quickly. If you guys are still, if somebody's still lost, just follow along. A, B, we'll go a little wider. A, B, I'm gonna do it on the same one over here. Okay, I'm gonna go to B, C. It's a shorter one. I'm gonna go to C, A. Okay, there it is. So I'm going to outline that in red. So there's my perimeter of the obtuse. Triangle. All right, good. How we doing? Okay so far? We got a couple other things we need to do. All right. Here's the next one with the construction. I'm gonna get a fresh piece of paper. All right, so start off with a segment, a random length. We're gonna call this a segment AB, random length. And I'm also gonna put a second segment. We're gonna call that CD. Okay, so I got two segments, A, B, and CD. All of your lengths could be a little bit different. That's okay. Now, what I'm going to do is I'm going to come up with a segment with the length of AB plus CD. All right? So that means I need a ray. Make sure my ray is long enough. So there's a ray. I'm going to copy AB. This is very similar to the perimeter of a triangle, so not much is changing. We can go a little quicker. Start with A, widen out to a radius of B. It's a little long. Move it in just a tad bit. There's B. Don't let the compass move on you. So there's AB. And now I'm going to go down to the CD. Right where B point was, that's where I'm going to pick up and now do CD. And so from A to D, AB plus CD is equal to AD. Does that make sense? If I were to put numbers to it, let's say AB is a length of 5 and CD is a length of 4, that means AD is a length of 9. Everyone okay with that? Pretty simple, right? All right, let me throw a little curveball at you. Find the length of a segment that's AB minus CD. Oh, Mr. Bennett, that is a challenge, isn't it? All right, so I'm going to go ahead and put a ray down. I'm going to copy AB out there first. And copy AB. There's AB. All right, now I'm going to copy CD. But instead of extending it out like I'm adding it to it, I'm going to turn my compass around and I'm going to go the other direction. Ooh, look at that. That is clever. It's like I'm taking it away. So then C, and then this point is D. So if I went out AB and I'm coming, almost like a number line, right? Like on a number line. And so then my ABCD is represented by that itty bitty segment. If I were doing numbers again, if the AB was 5 and DC was 4, what would be the length of AB? 5 minus 4, which is 1. Hunter, does that make sense? Good. AJ, does that make sense? All right, let me throw another challenge at you then. You use the same lengths for A, B, and CD, but this time do this. 2AB minus CD. What does the 2 out in front mean? There's 2 of them. Or you multiply it by 2, same thing. Go ahead and do it. Put down array. Copy AB twice. When I do it twice, that represents 2 of them. I'm going to do it again. If my compass doesn't move, I don't need to verify. That represents AB. So then that length from here to here is 2AB. That makes sense? Does that make sense? Now I got to subtract away CD. I'm going to copy CD, and I'm going to go backwards. Could I start at A and take it away? Yeah, you can. I just like thinking of it backwards. Okay, so then that represents CD. So I went 2AB out, and I went backwards CD, kind of like on a number line, out and back. And so the remaining portion, let me outline it in red. That part of the segment represents 2AB minus CD. Okay, does that make sense? Yeah. Great job. Let's do another one. Do 3AB minus 2CD. (3AB minus 2CD). Those of you that are stuck, watch me. I'm going to do it real quick. Should not take us very long. AB, AB, AB. There's 3 of them. Now let's subtract away 2 CDs. Like a number line, subtract away. There's 1 CD. There's 2 CDs. So that means what is remaining, I'm going to outline in red. Here, there, represents 3AB minus 2 CD. All right, everyone good there? Okay. All right, we have no homework for tomorrow. We're going to move on in the constructions. That does it for the day. We turn off our recording.